Okay, let's continue. We had the sum of those matrices in the example there, and then we did that also with the help of Excel and also with the help of calculator. Some calculators have this possibility to calculate with matrices. And then there is the calculation rule for multiplying a matrix by a number. This is also quite simple rule. If you have to multiply a matrix with some, for example, number with number -3, for example, in this example, and you have to multiply -3 times this matrix. So all what you have to do is to multiply all elements with the same number. So this is very easy rule. In Excel, this is actually not so easy to do, because if you want to do this kind of calculation with Excel, I will do that here. If I, for example, have this number -3 and I want to multiply with this matrix, let's see that this is matrix there. So this multiplication has to be done. To do this with the one command, you need to do so that you just pick that -3 there, and then you know that you need to use the same -3 all the time. So you multiply with this -3 all the elements of inside that matrix. Then I have to use the function buttons here. With the Excel, I may press the button F4. Now I first picked that value there, and if I press F4, then it gives us these dollar signs there, and this means that it locks the column A and row 7. That means this cell. This locks that cell, and this is what I want to do. And then I multiply that with number 5 there, and that B7 I'm not going to lock. That can be like that. So this is okay. And now, because I have locked the number -3 there, so that will use always the A7 cell here. Then I copy this to the right and down. So as you see, now it multiplied with -3 all the elements inside the matrix. So the same result as in here, in this example there. All elements are negative, has negative values. So that's because all was multiplied with negative number. And then there is also possibility to do exactly same as in basic algebra you can do. For example, if you have, I will use the camera here. For example, if in basic algebra you have, for example, this kind of case that you have 2x plus 4y plus 8 zeta. Then you can take a common factor. They are all even numbers, so we can pick the 2 outside of brackets, and then I will leave x plus 2y plus 4, 7. So this is a common factor 2. And the same thing we can do with the matrices, because here in this example I hate this right now. Here we have all numbers inside the matrix. We are all those numbers or all those elements inside that matrix are divisible with 4. So I can take that 4 outside of the matrix, and then I will just divide all these values inside the matrix by 4. So that leaves us 1, 2, 4, 8. So this is also possible to do with matrices. So there are many same rules or same kind of rules as we have in basic algebra. Subtraction of matrices, well, this is also a simple rule, because if you want to calculate the difference between two matrices, you just calculate that difference by using corresponding elements. So for example, if I have a minus b, I have to calculate a minus b. So that means that I have to take elements from matrix A and subtract the elements of matrix B. So as you see here, 2 minus 1, or this element here minus this element here, that gives us the element of the subtractor matrix. Simple way to do. Well, in Excel it is as simple as in addition. For example, here I calculated the sum of these matrices here. I just wrote the formula which added those corresponding elements. If I had to calculate the subtraction of those matrices, I just changed the minus sign here. So it is as simple as that. But here you notice that I have here in this example I have also the matrix C, but it is of different type than the matrix A, because A matrix has 2 rows. Well, also C has 2 rows, but A matrix has 2 columns, but C matrix has 3 columns. So it is impossible to calculate A minus C, because they are not the same type or not the same dimension. And also it is not possible to calculate C minus A because of the same reason. So in addition and also in subtraction, you need to have a same type in those matrices. But then the matrix multiplication, all the rules to this point have been, in my opinion, very simple ones, very logical. You probably would have invented the same rules if you had to invent matrix calculus by yourself. But this matrix multiplication is a different one. I will show you the rule for that, or do I show it? Find that from, yes, here in my formula book it is told the rule for the matrix multiplication. This matricien tulo, that means the multiplication of matrices. And it is not so easy to understand what does this rule mean, even though you understood Finnish language. Well, this tells us that A is of type m by n, and B is of type n by b. So the production matrix, or the matrix multiplication AB, the matrix which we get by multiplying A and B, is of type m by b. If we check that, where is that m? M tells that this A matrix has m rows, and B tells that the B matrix has B columns. The first number tells always the number of rows, and the second one tells us always the number of columns. So the result, the product matrix, will be of type m by b. So the row number comes from the A, and column number comes from the B. And those numbers, n and n, are same. So that means that when we multiply two matrices, we has to have always in matrix A the number of columns the same as in matrix B has rows, the number of rows. Those numbers has to be same. So what does this mean? Probably this is not so easy to understand. I will use. I prefer to use example. It is quite simple if you see some examples how to do that matrix multiplication. But from this formula, it is almost impossible to understand. What does that mean? I'm not even trying to explain that. So in this text, there is said that the matrix multiplication will be calculated by some kind of dot product manner. If you remember from vector calculus, this dot product, if we had, for example, 2, 3, and then dot product, for example 4, 5, and how did we calculate this? We took the first elements or first components and multiplied them, so that will give us 2 times 4, and then plus 3 times 5. This was the method. If I change this a little bit, I will write this like this. I'll write this second vector in this form. So now it is probably more it looks a little bit or more similar than in matrix multiplication we do. We have a horizontal row and vertical column, and the same rule holds. First elements 2 times 4, and second elements 3 times 5 plus between them. So this is actually the method how we calculate the method which we use in matrix multiplication. Let's see again the example. So if we have this kind of example, we have to multiply these matrices A and B. So what do we need to first find out? We need to check that is the number of columns in this matrix is the number of columns in the first matrix the same as number of rows in the second matrix? So if we want to multiply A times B, multiplication AB, the first matrix is A and it has 3 columns, and the second matrix is B and it has 3 rows. So that means that it is possible to calculate that matrix product. This is important. You can't do that matrix multiplication every time. And it is good to notice that in matrix multiplication mostly A times B is different from B times A. So the order of multiplication is important. AB is not the same as BA. This is a huge difference if we compare this for example in basic algebra. In basic mathematics we have, for example, 2 times 3. It is exactly the same as 3 times 2. So the order of the multiplication is not important in basic algebra, but in matrix algebra this order of multiplication is very, very important. So you have to be sure that you multiply them in correct order. So when we start to calculate this, in some mathematical programs you actually don't need to know if that multiplication is possible or not. If you just type that multiplication in that program, that gives you some kind of message. Probably it gives some kind of error message that this is not impossible to do. Many times if you try to do that, you get some kind of error message that has the name or word dimension in that message. There you may get the error, dimension error, and in that case, in matrix examples, that tells that you are not possible to do that kind of multiplication. I will check if I take this calculator. I don't remember how my calculator does that. For example, if I have, for example, these matrices which I entered here. Those were those examples which I used when I multiplied the sum of those matrices. And if I try to multiply these matrices, this times this, I will take that. I will pick that matrix and multiply that with this matrix. So at this moment it looks like a pretty nice. And this is what I meant when I told that probably if I had invented the matrix multiplication, I probably have chosen the same rule as was used in the sum and subtraction, in addition and subtraction. So I probably would have chosen the calculation rule in matrix multiplication so that I will multiply 2 times 5, that will give 10, then 3 times 1, that will give 3, 4 times 4, that will give 16, etc. So exactly the same rule as in the sum of matrices. But when I now try to get the result from this kind of multiplication from my calculator, I press enter now. It is a Finnish error message, but if I translate this, error is virhe, mittavirhe. I think this is not a correct translation. In this place, probably in English calculator, here would have read dimension error. That mittavirhe is not exact. Mitta is a measure in Finnish, virheis error, but this is not any measure error, but probably can understand what this means. And here in freely translated that this kind of matrix is not possible to do because there are not enough elements in those matrices. If I translate this is a very freely, so it is not possible to calculate this kind of matrix multiplication. I will check that also with Excel. What does my Excel gives when I try to calculate that, but I will not do that yet. So first, when you start to do matrix multiplication, if you do that by hand or if you do that by Excel, you need to do this kind of type examination or dimension examination, checking of type or checking of dimension. And if you have to calculate A times B in this order, write those matrices in a row and then add those types there. So this A is a type 2 by 3 and the B is a type 3 by 3. And first thing you check is those middle numbers, in this case 3 and 3. If those numbers are same, that means that it is possible to do that, the matrix multiplication. Because those numbers are, the second number tells here this 3 tells us the number of columns in the matrix A, and the first number here tells us the number of rows in the matrix B. And as I told there, you have to have the same number of columns in the matrix A as you have rows in the matrix B. So this tells these red numbers there tells us that they are equal, so it is possible to calculate. If they were not equal, if they, for example, in the B matrix would have been, for example, 4 rows or 2 rows, then it would have not possible to calculate. We just checked that by using my calculator, and there I had 2 matrices which were both 2 by 3 matrices. So this was the reason, because it was not reason for that it was not possible to calculate. But then with this type examination we can see more than only that is it possible or impossible to calculate, because those outermost numbers there, here we have number 2 and here we have number 3, they do not have to be same, but they tell us the dimension of the production matrix. So the production matrix will have 2 rows and 3 columns in this case. If this B matrix would have such kind of matrix that it had, for example, 7 columns there, so that would have so here 7 columns, now it has 3 columns, but if it had 7 columns, then it is also possible to calculate, but then the result matrix or the product matrix would have had 2 rows and 7 columns. If this A matrix would have had, for example, 10 rows, now it has 2 rows, but if it had 10 rows, then this number would have been 10. It is also possible to calculate, but then the result would have 10 rows and 3 columns. So when you are calculating this by hand in hand and paper or pen and paper, then this is important to do, because with this method you may choose the place for that matrix in your paper. You know that, for example, in this case the results will have 2 rows and 3 columns. So you need to reserve a space for that kind of matrix, 2 rows and 3 columns. So when we start to calculate the multiplication, and here it was said that it was some kind of dot product manner. And when I start to calculate the elements of the product matrix, in this case the name of the product matrix is C. So the first element in the matrix C is 1, 1, or first row and first column. If I do this by hand or with a pen and paper, I would do so that I will have C matrix here, and I will take a space for that matrix, and I notice that the result will be 2 by 3. So I will have 2 rows, so probably I would use for example this kind of line here. That gives me an impression that I have 2 rows in this matrix, and then I needed to have 3 columns in that matrix, so I probably would do like this to help understand that I really have 1, 2, 3, 1, 2, 3, and 3 columns, 2 rows and 3 columns, so totally 6 elements in the product matrix. And now if I start from this element in the product matrix, this element is located in the first row and first column. So this is element C11. And when I start to calculate that, I will take the in this example I have used the color to show how do I calculate that. So I first, because the element is 1, 1, so this first index here, this 1, tells us that we need to use first row in the first matrix, so these red numbers here. And the second index here tells us that in the second matrix I need to take first column, so these red numbers here. And between these red numbers here I will do that kind of dot product as I did in the paper a little time ago. So I multiply first elements and second elements and third elements and add plus sign between them. 5 times 2, 2 times 5, 3 times 6. So this is the method to calculate the first element in the product matrix. It will give us 38. And the same, so now we would have find the place value in this first element place here in the matrix C. So if we actually you can solve this in whatever order you like, but maybe it's logical to go in the first row first. So the next place would be in the first row and in the second column. So it will be the element C1, 2. And here you can see the method C1, 2. This tells us that the first matrix you need to take first row, and in the second matrix you need to take the second column. So those red ones here. And again the same method, 5 times 4, 2 times 2, and 3 times 1. And that will give us the result 27. And this continues. We get the third element in the in the first row, or this part here. It is the first row and third column, so we pick the first row in the first matrix and third column from the second matrix. So this is very simple mathematics, but you need to be careful to take the correct elements there. So again, 5 times 3, 2 times -1, and 3 times 9. That gives us 40. And then we move to the second row. So now we have found the values in the first row. Then we start the second row, and this second row is the row number is 2 and column number is 1, so the element is C21. So now we take the second row in the first matrix and first column in the second matrix, and again the same calculation rule. Then C22, or the second row, second column, so from the first matrix, second row, and from the second matrix, second column, and again the exactly the same calculation rule. And then the last one, C23, or that is the last element of this matrix, second row and third column, we will get from this calculation. Oh, I haven't used the red color here, but the second row and third column, the same multiplication rule. So this will be the result. So as you see, these numbers in the product matrix, they actually are almost impossible to guess by just watching those matrices. For example, these matrices you see from without calculation, you can't guess these values. You actually need to calculate everyone individually. So how do we do this? By using, for example, let's take this calculator first, and then I will use the Excel. This calculator I take because, for example, in MathCAD or this kind of mathematical programs, there is a quite similar way to calculate with the matrices. So I will add first that first matrix. Again, I will use these square brackets, and then the first row, it will be 5, 2, 3, and then the second row 7, 1, 4. So here are the elements of the first matrix, or this is matrix A. In this calculator I may add this to memory to matrix A. Here is a store button here. I choose that and choose that this is a matrix A. So in this case it tells us the matrix, it looks like that kind of matrix, and it is saved or in the memory in the place of letter A. If I choose the letter A and press enter, that will give us that matrix. And then I will do the same with the matrix B. I will that, oh sorry, you can't see, or probably you can see when I show both at the same time. So the first row inside square brackets, so that is the second matrix here. So I take 2, 4, 3, that is the first row, then second row also inside square brackets, 5, 2, -1, and then the last one also in square brackets, 6, 1, 9, elements are correct, and then I will save that to variable b and press enter. So now we know that b is the matrix in the variable b is the matrix b. And when I want to calculate what is A times B, I will multiply A times B and press enter, and that will give us the result. And as we see from the PDF file, that we get the same result. But if I multiply this in opposite order, B times A, B times A, what happens? Again the same error message, dimension error in English. So this is not possible to do, because this A and B, if we compare these matrices, let's do that in the opposite order like this. First we have this matrix B, and we try to multiply that with matrix A. So first we will take the first row from the B matrix and first column of the A matrix. But here we have 3 numbers and here we have 2 numbers. We actually can multiply 2 times 5 and 4 times 7, but this 3 does not have any company in the second matrix A. So that means that it is impossible to calculate. So as I told, I use this calculator only to show that in many mathematical programs you use the matrix calculation with a very similar way than we do with this calculator. But then let's check how to use the Excel in matrix multiplication. I will write the matrix here. So I have this matrix A. It was 5, 2, 3, 7, 1, 4. This is matrix A. I will use this line in around it. Actually, the Excel does not need this rectangle there, but it needs only the values of the matrix, or the elements of the matrix there. So this is the first matrix, and then the second matrix: 2, 4, 3, 5, 2, minus 1, and 6, 1, 9. So this is the second matrix. And now when I use Excel, I need to know the dimension of the product matrix, because I need to take a space from this sheet so in which part of this spreadsheet I will get the result. So I need to know what is the dimension of the product matrix, and because this matrix is, I will write it here, x times or x by 3, and this matrix is 3 by 3. So the middle numbers here, 3 and 3, they are same, so we can calculate that matrix multiplication, and the dimension of the result will be 2 times 3. So the first number and the last number. So we need to get the space of 2 rows and 3 columns here. So I will paint here that kind of space here. 2 rows and 3 columns. And then I will do that again, but I will write or type the commands in Excel here. In Finnish, I'm not sure if in English. In Finnish we use only small case letters there, but probably in English we need to use uppercase F. This command is mkerro. This kind of command, mkerro. But in English version, because I have Finnish, you can see there is Finnish text in the Excel. But in English version, you can have to use mmalt. This kind of command. And how do I do this? I will use the space. I found out 2 rows, 3 columns, so there is painted that kind of area in the spreadsheet. Then I start with the command mkerro. If you use English version, you write there mmalt, and this gives us some kind of advice. You need matrix 1 and matrix 2. So first you paint the matrix, the first matrix, and it will be this matrix here. So I painted that. You can see the command exactly a little bit. Probably you can see it from the formula line or row here, but I will show you that after I have get this ready. You can see what is the exact command. So first I painted the first matrix, then I take this, I don't know what is the name in semicolon, this mark, not comma and not dot or point, but semi something between them, and then the matrix 2. So I will paint the matrix 2. And then I end the brackets. And the most usual error comes when you just press enter, because what will happen when I press enter? I see. I have to say that these new Excels are better ones. They have corrected the problem. Yeah, I noticed that I've made this too complicated with the too complicated method, because in older versions of Excel you need to use the combination of 3 buttons: Shift, Control and Enter. So usually I will show you it from camera. In older versions of Excel, you did not press enter, but you press Shift button, Control button and Enter button. So 3 buttons combination, and that gave you the matrix multiplication or all the matrix commands which you use in Excel needed that button combination or typing combination. But in this new version, that problem does not exist anymore. So here you can see the result matrix, and as you see, it is the exactly same as we got from, for example, from calculator. Or did I did that here? Oh, so you don't see. I will take that again. So that yellow part of the Excel is the same, has the same numbers, values there as in my calculator. So this was a news for me. I don't know how long this property has been in these new Excel versions, but it is not so long time ago when it did not yet be that this was not yet there, because in older versions of Excel, if you just pressed enter, it gave you only the first element of the matrix. So you always needed to do that combination of the three buttons there. But let's check if we try to multiply this in different. I will check if I choose this kind of path here, and this is all which I haven't checked in new Excel versions. I will do again the. Oh, I forgot to write the formula here in this Finnish version. The formula is like this in the yellow area, and in English version you have to use mult. Oh, sorry. But I will check what happens when I try to calculate this. In an opposite order. First this, and then this. Let's see what it gives us. Value, error, value error. I don't know if that tells anything more, but this tells us that there is some problem with that multiplication, matrix multiplication, but it does not tell more. But this is a error that actually in this case tells that if I try to multiply those in different order, then it is not possible to do that kind of matrix multiplication. So here in this example I did this example 13 already, because I tried to calculate that matrix multiplication in different order, and that it was not possible, and that was because those middle numbers of those types were not equal, so it was not possible to calculate. So this is important to notice, that in matrix algebra, A times B is not the same as B times A. Even though in these examples I used the AB was possible to calculate, but BA was not possible to calculate. But even though they were possible to calculate, mostly they will not give the same result. There are some exceptions. In some cases they will give the same result or same product matrix, but mostly not. Then we have this so-called transpose of a matrix. This is actually not any kind of calculation rule. This is only a way to write the matrix in a different way. Probably this is more easy to understand if we take the example. So, for example, if we need to create a transpose of a matrix, in Finnish it is almost the same as in English. Here I will show the formula book again. Let's take the Excel away. here we have this so-called transponoitu matriisi here. Transponoitu matriisi. It is same as transpose of a matrix. Actually, I mostly use in Finnish, I use the word transpoosi. Again, the name in Finnish has a I letter in the end of that. Like in matrix, we change that to Finnish matriisi, I letter in the end of that. So transponoitu matriisi or transpose is the same. And what does happen when you do a transpose for a matrix? Well, easy. You take the first row and write it as a first column. Then you take the second row and you write it as a second column. So it is not any kind of calculation rules. It is only a way to write the matrix in a different way. Of course, there are some calculation rules where you need transpose of a matrix, but that transpose is exactly a very simple way to do. You just write it in a different way. One reason for when you can use the transpose is, for example, this kind of situation. You have a matrix where you have many rows. In this example, 9 rows. 9 by 2 matrix, 9 times 2. 9 rows, 2 columns. It takes a huge space from a paper. In this case, 9 rows. But if you write it as like this, A transpose, this exponent t tells us that it is a transpose. So you can write in with only 2 rows there. So this is one reason why this transpose has been invented, because it gives us a possibility to change the orientation of the matrix. By the way, in Excel, there is a command called transpose in Excel, but I am not going to do that, but I will show you another thing. For example, probably you have seen this kind of situation. If, for example, you have 1, 2, 3, 4, 5, for example, this kind of a situation, and you need to you want to write these numbers in horizontal way. Now they are in one column, but you want to write them in horizontal, so in one row. You may do this like this. You copy this, Ctrl C. I copy that. I pressed Ctrl and C. So I copied them, or of course I could use only also the right button of the mouse and copy or in Finnish copy. Now I copied that, and I want to put that those numbers, for example, here, but not in the vertical orientation, but in horizontal orientation. And one possibility is to do in Finnish liitä määräten. In English version, here you can see paste special. I chose that, and here you can see the last one, transponoi, in English transpose. So I select that and press OK. So this will give us transpose of those numbers. So I press OK, and now it painted it in a horizontal position. And also, if you want to do so that you have those values in horizontal position, but you want to give them in vertical position, then you again copy those numbers there, select the place where you want to add them, but in vertical position. Again I chose paste special, liitä määräten, and transponoi, transpose. and OK. Now it gave it in the vertical position. We could also use the formula, but I don't. This is not. Well, many times this can be helpful, but I could do this like this, because I know here I have 5 elements here in this matrix. I may think that this is a matrix which has 1 row and 5 columns, and I want to transpose them. I may do this like this. I select the space of 5 rows, there 1 column and 5 rows, and then I write the command transpose, or in Finnish transponoi, in English transpose, transpose. I will take that command and I will get this matrix there. And again, in older versions in Excel, we needed to use those combination of 3 buttons: Shift, Control, Enter. I am doing that right now. As you see, it gave us the transpose of those numbers. By the way, from the formula row you can see we have those different kind of brackets there that tells us that this is a matrix command. I'm not sure how does this newer version of Excel. In older versions you could not take away, probably I guess it holds still. I probably can't take anything away. I tried to delete some numbers from here. I press the delete button, and it tells that you can change the part of matrix in Excel. So because these are written here with the transpose command, then you can take anything away from that. But here these numbers, which looks like exactly same, these are only copied and pasted. So in this case I can take them away if I like. So there is no problem here. But this is a matrix command, you can't take these away. And then we have one special calculation rule which holds in transpose or of a product. I have an example in below here, so we can check that this actually holds this rule. If you need to calculate the transpose of a product, it is a product of transposes but in different order. So if you have here A times B and transpose of that, and you see the rule, we take transposes of both matrices, but we write them in different order. Here A before B and here B before A. And now here I have checked the calculation rule. I will take that, use also the calculator there to check that this holds. I have here A matrix 2 by 2 and also B matrix 2 by 2. And I have given here an exercise to check that this actually holds. So if you multiply those matrices with each other, that will give you the result of this kind of matrix. Let's see that from a calculator, so we can see that it's okay. I will enter the first matrix there. 1, 2 and then 3, 4 and then I save that in the A matrix. So it is now A, and the same with B matrix. 5, 6 and sorry about my camera, it is not so good quality. 7, 8 and this will be the matrix B. So when I calculate the A times B, I get this kind of result. As you see from the PDF file, it actually gives us that kind of matrix. Transpose, I have to check, I don't remember the command of here we have a command transpose, transponoi. Yes, it was like this. I will take that away. In this example, I have A times B and transpose of that. So I will take A times B in calculator and then I select the transpose from the matrix command list here, transpose. It gives us the small t as an exponent, that is a transpose. And as you see, the transpose changed the rows to the columns, so it is the transpose of that matrix there. And the rule here says that if I take a transpose of matrix B and transpose of matrix A and multiply them, then I will get the same result. Let's check. B transpose like this. There you can see B transpose times A. I have a feeling that I can do this more simply with this calculator, but I don't want to try to learn it like right now. I will just take them from that. Like this, B transpose times A transpose, and if I press enter, you can see that I got the same result as I got from the first version. A being transpose, that is the same as B transpose A transpose. This calculation rule, there are some situations where you need this rule. So that's why I put it in this PDF file as an example. So as we see from this example also, we get the same result. Then I have the last one. This matrix inverse, I think I will leave this to I think we have on Friday next time lessons, because this takes quite a long time to go through this example, and I don't like to be in a hurry when going through this example. I think you may read this by yourself. I will take some other examples in Friday's lessons, and I will continue with this matrix algebra. As you see that this was a PDF file which was named as Matrix Calculus Part 1 from the no, not this, study material for vectors and matrices, and this was from from the PDF file called Matrix Calculus Part 1, and I will add the Part 2 during this week, and during Friday's lessons I will go through the more of matrix calculus. I have prepared some new assignments, but they are not yet in that kind of step that I can give them in the Moodle, but probably during this week before Friday's lessons, I guess maybe on Wednesday or maybe even on Tuesday I will add those next. Probably there are three new assignments, and they concern of matrix calculus. So you will find them in the beginning of this week. But I think today I will end our lessons at this point. But I recommend you to read by yourself this concept matrix inverse before we go through that together. There are some examples there also. By the way, in some cases I have written there or written in the PDF the Excel examples also, and here as you see, I have written of the button combination Shift Control Enter, but as we saw today, it was a new thing for me that these newer versions of Excel, it does not need that anymore, and this is a good change, because this was always a problem when using matrix commands in Excel, because you always had to remember of that three button combination, and if you forgot that, you need to do the same thing again. So it took too much time to enter those matrix commands there. Yes. But then I will add there are some examples, but we'll read this carefully through. But I will add some applications of matrix calculation to the Moodle during this week, and in the Friday's lessons we will go through some examples there. So thank you for today's lessons, and let's see you on Friday, and of course if you have some assignments to do check, so just send me them and I try to check them as soon as possible. During last week I had so busy time that I think some of assignments I don't remember if you have sent me, but there were some assignments which took almost a week to check, but that is not so usual thing. But last week was a very busy week for me. But have a nice day and hyvää iltapäivää, and let's see after on Friday. Nähdään perjantaina. Bye bye.